Let's talk about one of the most nerve-wracking moments in engineering, deploying a rewrite to production. You've spent months rebuilding a critical system. Tests are green, code looks great. But there's still that nagging question. Will it actually behave correctly with real production workloads? The parallel run pattern gives you a way to answer that question with confidence. Instead of crossing your fingers and flipping the switch, you run both your old system and your new system side by side, compare their outputs, and catch discrepancies before they affect customers. By the end, you'll know what the parallel run pattern is, how to architect the traffic routing, and most importantly, how it solves that fundamental validation problem every rewrite faces. Here's the thing. You can have comprehensive unit tests, integration tests, end-to-end tests, but production has a way of surprising you. Real customer behavior is messy. Edge cases you never imagined. Data patterns that only emerge at scale. That payment system rewrite might handle your test scenarios perfectly, but what about the merchant who sends requests in an unusual sequence, or the edge case that only happens once every 1,000 transactions? Traditional testing can't fully replicate the chaos of production, and that's the validation gap we need to close. Your new system might calculate a refund as $10.04, while the old one rounds to $10 even. Seems tiny, right? Multiply that across 1 million transactions, or maybe your rewrite handles UTC timestamps slightly differently, and suddenly subscription renewals are off by an hour in certain time zones. These aren't bugs your staging environment will catch. They're the subtle differences that only surface when real money and real customers are involved. And the stakes are high. One miscalculation can cost you thousands in revenue and trust. Here's how it works. You route real production traffic to both your old system and your new one simultaneously. The new system processes everything just like it's live, but you only return the old system's response to your users. Behind the scenes, you're comparing outputs, logging discrepancies, and building a statistical picture of how your rewrite actually behaves. It's like a dress rehearsal with a real audience. No one knows they're part of the test, but you get authentic feedback before the curtain officially rises. Let's walk through the mechanics. Your production request comes in. You send it to the old system first. That's your source of truth. At the same time, you fire off the same request to the new system. If the new one crashes, doesn't matter. You catch it, log it, move on. Then you compare the two responses asynchronously, so there's no performance hit. The key insight here, you're only returning the old system's result to the user. The new system is completely invisible to production. It's running live workloads, but without any blast radius. Two main approaches here. First option, handle it at the infrastructure layer with a reverse proxy like nginx or Envoy. They intercept the traffic before it hits your app. Second option, do it in your application code itself. That's what you're seeing here in TypeScript. The router handles the request with the legacy system, fires off that shadow request to the new system without waiting for it, then immediately returns the legacy response. The shadow call happens completely out of band. Compare results later, log any errors, zero impact on the user's experience. Choose based on where you have more control and observability in your stack. Here's the tricky part, comparing those results. You'll get differences. That's guaranteed. The question is, which ones actually matter? Maybe timestamps are off by a few milliseconds because of network timing. That's fine. But if payment amounts don't match, that's a problem. You need to codify your understanding of correctness. Build comparators that know your business logic. What fields must be exact? What can drift? Define acceptable explicitly in code, or you'll drown in false positives and miss the real bugs hiding in the noise. When you hit a mismatch, don't just shrug it off. Log everything, the inputs, both outputs, a proper diff. Ship it to your monitoring system where you can actually dig in later. Track your match rate as a metric you obsess over. If you're only hitting 95% matches, you've got serious work to do. You want 99.9% or better before you even think about cutting over. Each percentage point is telling you something about your rewrite. Listen to it. Now let's talk about the elephant in the room. Write operations. Reads are straightforward. Query both systems, compare the results, no harm done. But writes? That's where people get into trouble. You cannot just fire off a payment charge to both the old and new system with real customer cards. That's how you double bill someone and end up in a very awkward conversation with your CEO. For writes, you've got two plays. Either shadow your writes to a test database that doesn't touch anything real, or lean hard on idempotency keys so duplicate requests get safely ignored. Pick your strategy before you go live. Let's get concrete. 3 ways to handle this safely. First, dry run mode. The new system goes through all the motions but stops right before actually mutating anything. Second, route those shadow writes to a completely separate test database that looks like production but can't hurt anyone. And third, the elegant solution. Idempotent operations with shared keys. Both systems see the same request, but the second one gets deduplicated automatically. Same key means the new system recognizes, hey, I've already processed this, and safely does nothing. Pick the approach that matches your architecture. Let's look at how Netflix pulled this off. They needed to move their entire queue system from SimpleDB to Cassandra. That's millions of users' data. Here's the brilliance. After forklift copying everything over, they ran shadow reads on every single query. Both databases answer, results get compared in real time, and any discrepancy gets logged. This let them catch data consistency problems incrementally, fix them without panic, and only shift traffic once the numbers looked rock solid. The whole migration? Zero downtime. That's the parallel run pattern proving its worth at massive scale. GitHub's MySQL migration is another great example. They had to move critical database clusters without any room for error. So they copied the data over with Percona Extra Backup, set up bin log replication to keep things in sync, then ran parallel reads against both the old and new clusters. Every query hit both systems, results got compared, and they watched replication lag like hawks. After weeks of this validation dance, zero discrepancies, they finally cut over. That's how you migrate production databases without giving your on-call team a heart attack. Let's be honest about costs. You're literally running 2 entire systems side by side in production, which means double the infrastructure spend. Your AWS bill is going to spike. But here's the thing, you don't need to run every single request through both systems. Sample 10% of traffic for the shadow system, run comparisons asynchronously so you're not blocking user responses, and set a hard deadline. Run this for a few weeks, validate thoroughly, then kill the parallel run. Yes, it's expensive, but it's way cheaper than explaining to your CEO why transactions are failing. Start conservative. Shadow read operations first before you touch writes. Run your new system completely async so it never blocks user requests. And here's critical. Log every single mismatch, even the tiny ones, because 3 small discrepancies might reveal one big architectural flaw. Set a finish line, say 99% match rate over 2 weeks, then pull the plug. The worst thing you can do is let this drag on for months while your team loses focus and your finance department starts asking uncomfortable questions. Let's talk about what goes wrong. Biggest mistake? Your shadow system crashes and somehow takes production with it. Bulkhead everything with circuit breakers. Second, you'll drown in discrepancy alerts. 90% will be timestamp differences or floating point rounding. Build smart filters from day one and watch for performance creep. If your shadow calls aren't truly async, you'll add latency to every request. Oh, and test your comparison logic as rigorously as the actual code. Finally, don't let this become a permanent fixture. 4 weeks maximum, or you're just procrastinating the real cutover. Parallel run shines when you're touching anything that handles money, recommendations, or core business logic. Anywhere a subtle bug equals real damage. It's also perfect for database migrations where you can safely duplicate reads. But skip it for brand new features. There's nothing to validate against. And if you're just swapping out a library, branch by abstraction is way simpler. The real killer is cost, though. If doubling your infrastructure spend makes your CFO cry, this pattern probably isn't worth it. Let's put this in context. Strangler Fig is your long game, routing traffic gradually over months. Branch by abstraction hides internal swaps behind an interface. Parallel run is different. It's your final validation checkpoint. Think of it like this. Use Strangler to control the rollout, branch by abstraction to clean up your internals, then fire up Parallel Run right before you flip the switch for good. It's short, expensive, but gives you that bulletproof confidence the other patterns can't match. Let's bring this home with 4 key points. First, real production data exposes the weird stuff, null values in places you didn't expect, time zone chaos, that one customer with Latin characters in their address. Second, your old system stays the boss until you're ready. The shadow just watches and learns. Third, keep this short, 2 to 4 weeks max. You're burning money running duplicate infrastructure, so validate fast and make the call. And finally, nail down what correct actually means up front. Floating point differences, timestamps off by milliseconds? Decide now or you'll drown in false positives. Bottom line, you're trading dollars for sleep at night confidence. Here's your roadmap. Week 1, pick something scary, maybe your order processing or billing, and build the replacement. Week 2, deploy it as a shadow that just observes. Week 3, wire up comparisons so you can see every difference. Week 4, unleash full production traffic and watch the chaos unfold. Week 5's the grind. Fix bugs until you hit that 99% match rate. Week 6, start shifting real users over gradually. Week 7, kill the old system. 7 weeks from nervous to confident. Martin Fowler's got a solid write-up on this. Check the link. All right, you've got the big 3 in your toolkit now. Strangler Fig when you're replacing entire services from the outside. Branch by abstraction when you need to swap internal dependencies without breaking everything. And Parallel Run when you absolutely need proof your rewrite works before you flip the switch. These patterns stack together. You'll use different ones for different parts of the same migration. Up next, we're diving deeper into feature flags, database migrations, and some brutal war stories from teams who've done this at scale. But first, go watch the Strangler Fig deep dive to see exactly how to carve up that legacy monolith piece by piece. Links right there.